Namaste everyone, it's me Shailendra. Welcome you to online Monastic classes. We will continue in OPT function chapter. Earlier we have talked something about that numerical, that theoretical part was completed. Now further we have to go and we have to do 1 mark question. In 1 mark question generally definition is asked. We have written all the definition earlier. So in 1 mark question, these are the terms which you have to define. You can define these terms. First one is algebraic function, linear function, constant function, like that. You can do the question number 1. We will start from the question number 2. One thing you must have to remember, if you know the basic parts of the exercise, then you will know the chapter nicely. For this, 1 mark question is very important. You have to know all the basic things of this exercise. Only you will be able to solve this type of question. Starting with question number 2. It is for what values of m and c in y equal f of x is equal to mx plus c, make it an identity function. We have learned identity function means f of x equal to x, that is y and x are equal. How it will be equal? For that, m must be 1 and c must be 0. So our answer is m is equal to 1 and c is equal to 0. If you put in place of m 1 and in place of c 0, what you will get? Y is equal to x. That's our answer. We have m is 1 and c is equal to 0. Question number 2b. For what value of m in y equal fx equal mx, only mx, next is a constant function, mx plus c, that's correct question, because mx plus c, max is a constant function. So you know that for constant function f of x is equal to c. We want only c, so m must be 0. So we can write m is equal to 0. If you put in place of m 0, then it will be y is equal to c. Question number 3. These are the things you have already learned earlier. These things you have to again learn in linear programming, but basic things you have to remember. In quadratic equation, graph of quadratic equation which we will get will be in the shape of this. This shape is called parabola. What is the name of the curve obtained by the graph of quadratic equation? That is parabola. One thing again you have to remember, when it's in the form of this, quadratic equation is given in the form of this will represent H and K represent turning points, coordinates of turning point, or vertex of parabola. So here in question number 3b, it is what does HK represent? HK represent vertex of parabola. In question number C, for what value of a, the parabola gives f of x equal ax minus h whole square plus k, where a is not equal to 0 has opening upward. This mouth will be opening upward. Condition is this value must be positive. It means question number C answer is a is greater than 0. Question number D, opening downward. For opening downward, a is less than 0. Now, question number 4a. You have an equation f of x equal ax square. When the equation is like that, ax square, whatever the value of a, we try to treat any constant value, we have always the center be 0, 0. Because if you arrange this in this form, the center becomes 0, 0. And for the symmetry, line of symmetry, we have formula x equal minus b by 2. Minus b by 2, what does it mean? The when quadratic equation is in this form, then vertex of parabola is minus b by 2a, 4ac minus b square by 4a. And line of symmetry is x equal the x coordinates of the parabola. So here the x coordinate is 0, so y equal to 0 is the vertex of parabola. Y equal to 0 is x-axis, so we can say vertex is equal to 0, 0, and line of symmetry is y-axis. Write the vertex of cubic function. When function is in this way for cubic, again same as this, vertex will be 0 for the cubic function or for the quadratic function. What is the y-intercept of y equals sin x? You have learned this value, y-intercept, x-intercept, this value you have written, studied. Now you have 6a, what is the maximum and minimum value? Again you have completed these things. So you can complete these 2, 5 and 6 yourself. You have to write the domain and range. Again you have completed these things. So it's your own work to complete 5, 6 and 7. If you have any problem, then look the earlier video and you have the table of these things, you can complete from there. Now coming to the question number 8. Here f maps A into B and C maps B into C. Then what will denote the composite function from A to C? The first it is A, here last it will be C. So we want f at first. So when we are writing composite function, so when you write in this way, it means we have to start from there. But we want this at first, so we have to write this. So here, what will be the answer of the question number 8a? The composite function from A to C is G circle F. Question number B. H map R into S and G map Q into R. What will be the composite function from Q to S? We want Q at first and S at second. with Q. That is Z will be first and H will be second. So we have to write H circle G. Now we should see which range of the function between F and G is equal to the range of range of the function F circle Gx. Range of F circle Gx is equal to range of Fx. Which range of the function between F and Z is equal to the range of the function G circle Fx? Range of G circle Fx equal to range of G circle x, that is Gx, G of x. Which domain of the function? Domain of F circle Gx equal to domain of F. Domain of G circle F of x equal domain of here we are mistaken. Here it will be domain of G, here it will be domain of F. When we have to write domain, we have to take the first one from there. And when we have to take the range, we have to take the second one. Question number 9a. F of x equal n, G of x is equal to n, and we have to find F circle Gx. You have learned how to find the composite function. G of x is n, but Fx is n, so it will be the n. But in constant function, what you have to remember, if a function is given like 2, whatever the value you will put, that's a constant function, so result must be 2. Whatever the value you put, result always be 2. B number, F of x is a, G of x is b. We have to find G circle fx. G circle fx, that is a, and G of x is b, so result in b. In what condition F circle G and G circle F are equal? F circle G and G circle F are equal when F and G are identity functions. What is the necessary condition to find the composite function of two functions? To find the composite function, if F and G are two functions, then necessary condition for G circle F is, that is, range of F is subset of, either it will be equal or subset of domain of G. Domain of G. Then in question number 11, you have to find the composite function G circle F. What you can see there, 11a G circle F. So when we write there G circle F is how to find? In such type of figure we will combine. That is A, B, C. X, here is Y, here is Z. That's F and that's G. We want to find from here to here. This is G circle F. Therefore, G circle F is equal to X, Z. That's our answer. From here, G circle F is M to S. MS will be here, it will be A to C. AC will be the answer. Now in question number 12a, that's the mapping diagram of a composite function. Later we will discuss about these things. 12a, F equal 1, 2, 3, 3, 4. C ordered pairs are 2A, 4C, 3B. You have to find the value of G circle F1. For this, first look what is the value of 1. What is the image of 1 in function F? Image of 1 is 2. So image of 1 is 2 here. Now image of 2 is what in function G? That is A. So answer is A. If you have to find F circle G3, same process will be applied. G3 is where B. Now you have to look there. In this question that not possible because the range is not same. If we take another question, G circle F2, what you have to do? Image of 2 is 3 here. Now you have to look image of 3 in function G, that is B. In this way you can find the results. 12, B and C are exactly the same question, so you can do yourself. Question number 13a. F of x equal x plus a. G of x equal x. We have to find G circle fx. G circle fx equal G inside the bracket, write the f of x. What is the image of x? X plus c. Now the result is G of x is x. So for us x is x plus c. That's our answer. Question number B is exactly the same. Question number 14. What is the domain of G circle F? We have discussed about these things. F 1, 3, 2, 1. Order pair of function G is 1, 2, 3, 2. Domain of G circle F. You know that domain of G circle F is equal to domain of F. So what is the domain of f? 1, 2. That's our function. Now, same question is 14p, so you can do this question 14p.